Hi everybody, in this lesson today we're going to be talking about quadratic functions, and so this is the beginning of our next unit. You have learned about quadratic functions before in Algebra 1, but that has been a while, so we're going to go over some of the basics. So today we're going to talk about characteristics of quadratics and then also talking about standard form. So starting out, what is a quadratic? A quadratic is any function where x squared is the highest power. So when we talk about linear, it's just like mx plus b, right? But when we talk about quadratics, we start getting to x squares. And that creates a shape that is kind of a U shape. It is a parabola, and that's probably a word that you've learned before as well. Okay, well, let's look at some characteristics. And when we look at a parabola, what are some things we talk about? Well, one thing we talk about is how does it open? In this one, I think you can see it's going to open up. We will encounter some that go the other way, but this one's opening up. Okay, does it have a minimum or a maximum point? So we studied a lot of these terms in our first unit, but that was at the beginning of the year. The minimum point is going to be way down here. And so it has a minimum. It does not have a maximum because it has arrows on the end. What is the minimum value? Remember, when we talk about minimum values, we are only talking about the y value only. So this is -5 here. So that's the y only. Okay, axis of symmetry. Again, a word that you have learned, but remember that's the line that basically cuts it in half. And so that's our axis of symmetry. When we give the name of this axis of symmetry, it is a line. And so we always say x equals, and in this case it is x equals -3. Then the vertex is at -3, -5. That is a combination of the axis of symmetry and the minimum or maximum value. Okay, domain and range. Remember that domain, when we talk about domain, we're talking about the x values. When we talk about range, we're talking about the y values. It basically means, as far as looking at a graph, how far to the left would it go? How far to the right would it go? And so the domain on a parabola is -infinity to +infinity. It goes all the way from -infinity all the way over here. Because these arrows, I'm going to exaggerate them a little bit. They're kind of going way out here like this. Okay, I've exaggerated them. But they are going to the left and right, as well as going up and down. Now the range is different. The range actually has a starting point, and it starts down here at -5, and it goes all the way up to infinity. Notice I put a bracket on there, a squared off bracket, because it does include that point. It does include the point -5, and then it goes up forever. Also in range, we always go from the smallest numbers to largest numbers. Okay, increasing, decreasing. Remember, this is when we talk about that ant. We always look at increasing and decreasing from left to right, and we always use our x values to describe it. And so from left to right, if we have that ant, and that ant is crawling down or crawling up, so where is it increasing? We're talking about the x values. Okay, sometimes we talk about increasing, decreasing. A lot of times, actually, people get confused on why are we talking about the x values. So in this section of the graph, it's decreasing, going down. But in this section of the graph, it's increasing, going up. Well, how would you describe this section on the right? You would describe it to say from -3 all the way up to infinity. So it is increasing, going up. The ant is crawling up the hill from -3 all the way to infinity. It is decreasing from -infinity all the way over to -3. So that's why we use the x values. Okay, another question, what are the roots, zeros, and x-intercepts? Those are all synonyms with each other. Even though they're synonyms, they all have just slightly different meanings, but they're essentially, we're all talking about the same point. So the roots or the zeros or the x-intercepts are right here and right here. And so we could say, well, then it says how many are there? And that's a different question that we'll get to as well. But first of all, there's one at -6, 0, and there's one at 0, 0. Now notice I gave them as coordinates. It is a coordinate. Now, if we're asking a specific thing, like what is the solution or the zeros, we might say x equals -6 or x equals 0. But if it has the word intercept in there, we need to make it into a coordinate. And then y-intercept, well, the y-intercept is also 0, 0. And the end behavior, do you remember end behavior? So end behavior is when we had these sentences, and it says as x approaches negative infinity, remember that means as it's going to the left, and as x approaches positive infinity means it's going to the right. So as it's going to the left, what is the graph doing? Well, it's going up, and up means positive infinity. And when it goes to the right, it's going up, and that does mean positive infinity. So a lot of these terms are terms that we learned back in our first unit. We are going to continue to work with those terms. Let's look at an example. Okay, you can take a second to look at this and fill in as many of these as you can. Will you pause the video here and see what you can fill in? Okay, let's see what you came up with. Hopefully you saw that it opens up. That means it has a minimum point. The vertex is at 0, 1. The axis of symmetry, that's that dotted line that splits it in half. That is 0. The max value is 1. Remember, that is the y value. And then the domain is from negative infinity to positive infinity. The range is up and down, goes from 1 up to infinity. No real solutions. The solutions, once again, are where it hits. It's like x-intercepts. And this one doesn't have any x-intercepts, so that's none. And so that's what we have down here. Y-intercept is 0, 1, which coincidentally is the same as the vertex. Increasing, it is going up from here over to here, from 0 to infinity. It's going down from negative infinity all the way up to 0. And behavior, because it's pointing up, both of the ends are pointing up. Okay, the next video we'll talk about standard form.